Hello everyone, I am glad that you joined me today. My name is Michał Wawrzeńczyk and I am refrigeration engineer at Areacademy, a training center inside the company Area Cooling Solutions, a European manufacturer of condensing units for commercial refrigeration. Today we will focus on CO2 refrigeration, but first please let me give you a few organizational information. The meeting will last around 45 minutes and will be divided into two parts. Over the next around 40 minutes, I will introduce you to the use of CO2 technology in commercial refrigeration, and the last around 5 minutes after the presentation will be devoted to your questions. Along with me, there are also Piotr Jabłoński, the Areacademy manager, and Patryk Majerski, the CO2 project manager. They will be available for you on the live chat during the entire meeting. So if you have any questions during the presentation, you are welcome to ask them, and our team will answer them. The important thing is that if you want to use the chat, you must click the button Create a channel. This is for YouTube security purposes. Thank you for your presence, and let's get it started. Recently, the general trend is that the European refrigeration market is moving toward natural refrigerants. I want to present 6 reasons why using the CO2 in the refrigeration installation is worth considering. The first and most impactful reason for this shift is the European F-gas regulation, which was revised and updated at the beginning of this year. It is a crucial driver in the transition towards natural refrigerants. One of the key findings of this regulation is the introduction of more restricted limitations, which will further reduce the HFC quotas in the refrigeration market. Based on this data, we have prepared a simple chart showing the decline in the availability of HFC refrigerants in the coming years. As you can see, in 2030, the quota of HFC will be 5 times lower than the limit set for 2025. The limit for 2030 is 95% lower than the reference value established in 2015, which was around 177 million tons of CO2 equivalent. The HVAC refrigeration market and stakeholders expect this will significantly increase the price of HFC refrigerants and corresponding HFC refrigeration solutions during the upcoming years. In the updated European F-gas regulation, you can also find the corresponding bans for our sector. And here I decided to present 3 restrictions for the stationary refrigeration units. The first, which has been in force since 2020, bans the HFC refrigerants with a GWP factor of 2500 or higher. This means that the popular 404 refrigerant can no longer be used. However, we can still use the 448 and 49 refrigerants. The next ban was applied to commercial multi-compressor centralized systems over 40 kilowatts. Since 2022, refrigerants with a global warming potential factor equal to 150 or higher cannot be used anymore. For such systems, for example in supermarket applications, we already started to use natural refrigerants like CO2 or propane, or slightly flammable A2L refrigerants. The upcoming ban is scheduled for 2030, covering stationary refrigeration devices regardless of capacity and type of application. Only refrigerants with a global warming potential factor of less than 150 will be approved. This means that from 2030, all new refrigeration plants will have to run on natural refrigerants, such as CO2 or on A2L refrigerants. In the official F-gas document, you can find some exceptions for safety requirements, cascade systems, and temperatures below -50 degrees Celsius. Another reason why CO2 is an interesting refrigerant is the list of advantages of CO2 over HFCs. For example, the price of 1 kilogram of CO2 can be even 80% lower than 1 kilogram of popular HFC refrigerants. With the same installation capacity, the pipelines in case of CO2 will be about 2 times smaller, and this is because of the very high volumetric cooling capacity, which can be from 5 to even 10 times higher compared to HFCs. Thanks to the high heat transfer coefficient, heat exchangers such as gas coolers or internal plate heat exchangers can be compact and they can work at much lower temperature differences. The global warming potential factor for CO2 is equal to 1, and it is used as a reference for other refrigerants. This in turn makes R744 refrigerant a long-term solution, since it meets all F-gas restrictions. It is safe refrigerant because it belongs to A1 group refrigerants because it is characterized by no flame propagation and low toxicity. And last but not least, the CO2 is a homogeneous substance. Thanks to this, there is no temperature glide and pressure drop. The system charging is also simplified. CO2 can be charged into the installation in gaseous form without the stratification problems that occur with zeotropic HFC refrigerants, 400 family, due to the different boiling points of the components. CO2 also has a high potential for heat recovery. The discharge temperature can easily reach over 100 degrees Celsius. We can use the rejected energy to heat up, for example, the domestic water. Due to its very good thermodynamic properties, it brings energy savings. There are installations where it has been confirmed that by changing the system from R404A to CO2, the energy consumption has been reduced by around 30%. Another reason concerns the proven CO2 technologies. The technology is already very advanced at this point, and yet it is still developing. On the refrigeration market, there are different available components dedicated to working with CO2, such as evaporators, expansion valves, pipes, liquid receivers, and other instrumentation and tools that meet special strength and quality requirements. And the last reason is the knowledge, experience, and support. Area Cooling Solutions has been developing CO2 technology in refrigeration units since 2016. Our production staff is highly qualified and constantly developing their skills. To support refrigeration market members, we organize advanced hands-on trainings in inverter and CO2 technology at Areacademy Center. So now we know that indeed CO2 has valuable advantages. Now let's look at the parameter values compared to the popular HFC refrigerants. We have here, for example, the R513A. It is an azeotropic mixture as a replacement for the R134A. And azeotropic means there is no glide of temperature. And there is also R448A. This is a zeotropic mixture as a substitute for 404A refrigerant. And as you can notice, the CO2 refrigerant has much lower critical temperature compared to other refrigerants and much higher critical pressure. Another interesting fact is that the evaporation pressure at minus 10 degrees Celsius is even higher than the condensing pressure for all other refrigerants. Accordingly, the condensing pressure for CO2 at 45 Celsius degrees is multiple times higher than for HFCs. As you see, CO2 is a very dense refrigerant, and this makes the compressors much smaller than those dedicated to working with HFCs. The fact that CO2 is a very good refrigerant is evidenced by its high specific cooling capacity. The evaporation heat for CO2 has the highest value in the table, as you can see. Now, when we know more about CO2, let's discuss the main differences between HFC and CO2 systems. We already know that CO2 technology is an ultimate solution, while the expected future for HFC technology is limited due to F-gas regulation. The transition challenge is due to the fact that the current market familiarity with HFC technology is still much higher compared to CO2, for which it is low or medium. CO2 installations are generally more advanced in terms of complexity and automation than HFC systems. Additional security features are required, like safety walls, additional sensors, and so on. Because of this, CO2, the systems are more expensive than HFC, but the price of CO2 refrigerant is much lower than that of HFC. In HFC systems, the pipeline diameters are bigger than in CO2 installations, and the heat transfer is not as efficient as in CO2 systems. In CO2 installations, the heat exchanger and compressors are generally more compact. And finally, there is also a big gap in the required temperature difference in the heat exchangers. As an example, in condenser for HFC, it is generally between 10 or 15, while CO2 needs much lower temperature difference value, around 2 or 3 kelvins. Let's go back to pipelines for a moment. Here you can see a visualization of the pipeline cross-section for R134A and CO2. The CO2 is more dense and has significantly higher volumetric cooling capacity. That's why the pipeline diameter for this refrigerant can be much smaller. In CO2 systems, the purity of the refrigerant plays a big role. To understand the information about the purity of the refrigerant, which is given on the cylinder's sticker here, let's analyze the table. For example, the 2.0 purity means that the quality is 99.0%. The digit before the dot, the 2, indicates the number of nines in the percentage value, while the digit after dot corresponds to the number in the last place of the percentage value. The purer the CO2 refrigerant, the better its thermodynamic properties, and the higher the efficiency of the system. We recommend using CO2 with a purity of at least 4.5. The operation of a transcritical unit from a thermodynamic point of view strongly depends on the ambient temperature. When the ambient temperature is low, for example during the winter, the unit works like a standard HFC unit. It means there is a condensation process of refrigerant here, because the pressure is below the critical one. Therefore, the gas cooler in these conditions works like a standard condenser. The situation changes when the ambient temperature is high. In such ambient conditions, there is no condensation process, because the pressure in gas cooler is higher than the critical one, and CO2 is in supercritical state. The hot CO2 gas is cooled by the air forced by a fan of the gas cooler. At the outlet of the gas cooler, the CO2 pressure is reduced by an electronic expansion valve, called the high pressure valve, to the pressure in the liquid receiver. Finally, the liquid CO2 refrigerant flows out of the unit and supplies the evaporator expansion valve. When performing a CO2 installation, it is crucial to remember that all components of the system must be certified to work with CO2 refrigerant at the required pressure. Remember to always pay attention to the PS pressure strength values of each line and the corresponding safety valves. Do not use fittings, service valves, safety valves, or other components with insufficient PS value. Always check the specifications of the component you want to install, as you can see in the example table from Caster's catalog. Here you can see is the information about the PS for this component, 120 bar. On this drawing, you can see a simple one-to-one CO2 installation. We have one transcritical CO2 unit and one evaporator inside the cooling or freezing chamber. CO2 refrigeration installations differ significantly from well-known installations working with HFC refrigerants. Such systems typically require more complex design, additional safety features, and more robust components compared to HFC systems. Therefore, we have prepared an interactive material that contains the most important information on how to route a CO2 installation. It is available for free on the Areacademy website, like all the other digital materials and articles we publish there. In the general information section, you will find information about how to place the unit properly, what is the maximum permissible ambient temperature at which the unit can operate, which material used for making brazing connections, what should be the purity of CO2 refrigerant, what pressure value to use for the pressure strength test and for the leak tightness test, and what is the required vacuum value before charging the refrigerant into the system. And many more information regarding the distances, supports, pipeline slopes, insulation, velocities of the refrigerant in the suction or liquid lines, and so on. I highly recommend you visit our Areacademy website and read this material in detail. And now it's time to discuss examples of the CO2 solutions available on the market. We have PowerPack CO2 rack systems and compact transcritical CO2 units. The PowerPack solutions, such as CO2 booster systems, are an example of the popular technology in commercial refrigeration sector. However, there is also a reasonable trend to divide big installations into several smaller ones. Such a concept is called the decentralized system. CO2 booster systems are centralized systems that can reach high capacities by multiplying the compressors in the same installation. This is a large and heavy solution requiring a machine room with detection, ventilation, and monitoring. In such systems, there is dependence of the LT and MT circuits, complicating the capacity regulation and suction pressure adjustment with higher inertia. The refrigerant charge is large, resulting in risk of high cost in case of leakage. And finally, during failure, the entire installation may be shut down. Another solution are compact transcritical CO2 units. This solution is dedicated for small and medium applications or extended decentralized systems, reaching similar capacities as rack systems by multiplying the compact units in independent circuits. This results in better reliability with a low risk of leakage. In such systems, the refrigerant charge per circuit is much lower than in rack systems. Also, the PED requirements are lower. Installation with compact transcritical CO2 units enables more precise parametrization and evaporator regulation. The commissioning and service is faster and easier. We also have more location options because pipeline diameters are smaller, circuits are shorter, and the units are compact. And of course, there is a possibility of step-by-step remodeling. No need to stop the business operation. The conclusion is that both solutions are good, but compact units combined with the concept of decentralization of the system ultimately bring a greater reliability, flexibility, and cost savings. Area Cooling Solutions produces inverter transcritical CO2 units since 2016. Currently, we have 6 CO2 inverter units in our standard offer. The newest and the biggest one is iCool 30 CO2, designed for medium temperature applications. It is equipped with tandem of inverter compressors, and each compressor has its own inverter. The MT capacity range is from 1.8 kilowatts to 26 kilowatts, and the low temperature capacity range is from 1.7 kilowatts to 8.7 kilowatts at minus 30 evaporation and 32 ambient temperature. Moreover, we are now introducing the simple CO2 condensing units family called iCool SE, which were successfully launched last year, but this time dedicated for working with CO2 refrigerant. When you decide to choose the inverter transcritical iCool CO2 unit, you will receive several added values. First of them is the energy-saving inverter technology. A characteristic feature of condensing unit equipped with inverter technology is capacity modulation by regulating the speed of compressor. This results in the ability to generate an adequate cooling power, always adapted to the current needs of the installation. Therefore, inverter condensing units feature significantly higher energy efficiency than standard on-off units, in which the compressor operates at only two speeds, 100% or 0. The inverter technology system consists of 4 main components: the low pressure transducer, the PLC controller, the frequency inverter, and inverter compressor. The cooperation of these 4 main components is presented in the visualization. The low pressure transducer sends a signal about the current suction pressure to the controller. From here to the controller. And then the controller is connected to the inverter and provides information if the compressor should speed up or slow down. And the primary function of the inverter is to change the compressor's capacity by controlling its rotation speed and power consumption. Summing up, inverter technology provides energy savings because there is less compressor start and stop cycles and less required defrost cycles, operation in wide capacity range. Better product quality, thanks to the stepless regulation adapting the capacity to the current installation demand. Inverter technology guarantees precise temperature regulation, ensuring the increased quality of the storage product. It also provides longer compressor lifetime because there are less on-off cycles and soft starts. And finally, it provides silent operation, thanks to the decreasing the noise level in part load conditions. The second added value when choosing iCool CO2 is the intelligent oil control system. Oil management is crucial, especially in CO2 refrigeration installations. The return of oil can be a challenge in multi-evaporator systems with capacity modulation. That is why iCool CO2 unit features an efficient oil management system consisting of the built-in software in the controller to push back the oil to the compressor, the oil separator, as standard, and electronic oil level sensors, the minimum and maximum oil level on the compressor. The visualization presents the fully equipped oil line in iCool 15 CO2. The oil line includes an oil separator, oil cooler, oil mechanical filter, the side glass, solenoid valve, elastic injection hose, and the minimum and maximum oil level sensors on the compressors. There is also dedicated shut-off oil service valve on the service panel. Solenoid valve controls the proper amount of oil inside the compressor. The logic is quite simple. The intensity of injection is directly proportional to the speed of the compressor. The higher the speed, the faster the solenoid valve opens and more oil is injected, as you can see on the visualization. Here we have 75% of compressor speed and the solenoid valve opens more frequently, giving more oil to the compressor crankcase. The third key feature is the integrated evaporator management. Depending on the iCool CO2 model, our multifunction unit controller can manage up to 2 additional expansion valves. In certain cases, the whole installation may be controlled through our built-in controller. Thanks to this, there is no need for the additional controller cost. The installation startup can be easier and faster. The control of the expansion valve and superheating is more efficient. And in case of lack of power supply, there are supercaps built in the controller with enough backup energy to close the expansion valves. There is also possibility to purchase a full connection box with an option to manage an external CO2 alarm. And the box includes the main electrical components and display. In addition to the standard added values provided by iCool CO2, the unit can be upgraded with various additional options, like high pressure fans to connect the air rejection ducts in indoor application, or an external receiver module to increase the refrigerant charge limit. However, for CO2, one of the most interesting options is the heat recovery solution. With heat recovery, you can get the hot water for free. This is a fully equipped system with an optimally sized plate heat exchanger. The entire process is managed by the controller, and it allows to reclaim the heat from the high pressure side, giving you the flexibility to use it for heating domestic water or glycol, among other possibilities. By taking advantage of the high heat recovery potential from CO2 with this intelligent heat recovery system, you will reduce energy bills. Now let's move on to some case studies of installations working with iCool CO2 units. Our iCool CO2 transcritical inverter units are designed for all seasons operations. These units can operate efficiently both during the winter, when the ambient temperature is well below 0 degrees Celsius, and also during the heat waves, when the ambient temperature reaches above 40 degrees Celsius. Recordings of our built-in remote monitoring and control system confirms that the reliability of our transcritical condensing units, especially at high ambient temperatures. And here you can analyze the graphs of the unit's operation during the heat wave in Cyprus and in Switzerland. The unit ran even above the operating envelope, but the compressor works all the time, and the safety valves do not open. We can see that it was almost 48 degrees Celsius in Cyprus and almost 44 Celsius degrees in Switzerland. Of course, the units are designed to operate at a maximum ambient temperature of 43 degrees Celsius, but here I just want to show you that even at higher temperatures, these units perform very well. This slide, in turn, shows the operating diagrams of iCoolCO2 unit installed in a store in Sweden. Both charts refer to the same unit in the same store. As you can see, our iCoolCO2 units are characterized by all seasons performance. They can work well at low temperature, like we see on the left diagram. There is almost minus 11 degrees Celsius, and also when the ambient is high, nearly 36 degrees Celsius in the graph on the right. Another case study relates to precise temperature control in the around 60 meter square freezing chamber in Europe, with the desired set point minus 24 Celsius degrees. In the beginning, the installation was supplied by an on-off solution with the 404A refrigerant. The critical temperature, minus 15 degrees Celsius, was exceeded too many times, as you can see here on the graph on the left. There were some moments when the temperature even reached plus 2 Celsius degrees. And because of this, the solution was changed to the CO2 on-off technology, the graph on the middle, which also was not provided by area cooling solutions. The situation was the same and sometimes even worse because the temperature reached even plus 6 Celsius degrees. Finally, an inverter transcritical iCool CO2 units by area cooling solutions were used. And you can see in the remote control recording on the right that the temperature practically does not exceed the critical point. It's thanks to the inverter technology. The unit provides very precise temperature control and adjusts the cooling power so that the conditions inside the chamber are suitable all the time. And the last case study I want to present is about the decentralized solution. Area cooling solutions performed remodeling of a 4,000 square meters hypermarket located in Hungary. The entire installation has been divided into smaller separated sections. A total of 26 iCool CO2 units were installed, finally. 70 units for the MT applications and 9 units supplying freezing applications. Thanks to the decentralization, the customer received the increased reliability and better quality of the product. And the biggest decision driver for the final customer was that the remodeling process was done step by step without stopping the business. If you would like to learn more about how to commission iCool CO2 inverter units, I invite you to visit our YouTube channel. And if you want to stay up to date with the materials we publish there, click the subscribe button. We will be thankful. We are aware that CO2 technology requires knowledge and experience. That is why we have created Areacademy, the interactive center of knowledge and technical support. Our main activities are hands-on and online training sessions, but to reach the global training demand, we also regularly create the digital training materials and publish the technical articles in 6 languages. I invite you to visit our website and check our training materials. If you want, you can also join our advanced hands-on training sessions focused on inverter technology, the use of CO2 in refrigeration, remote control and preventive maintenance features based on our iCool and Area Cloud solutions. Thank you for your presence and attention.